Right, we'll go through this. So this is the outcome 1 practice assessment. So this is at the back of those booklets that you've got in PDF form. Okay, so this is your rounding, scientific notation, ratio and percentage questions. Okay, so first couple of questions, rounding to decimal places and significant figures, and you'll see, well, this should be worth a mark a piece, right now. They're worth a mark each, right? That's not copied down. Anyway, right, so let's have a look. So the diameter of a steel bar is measured as 25.48 millimetres. Round this to 1 decimal place. So when you're rounding to decimal places, if you're rounding to the first decimal place, the second decimal place decides how you round. This 8 is going to move that 4 up to a 5. So all you would need to write for that is 25.5. Right, 25.5 millimetres. That's it. You don't need to do any working for that. Significant figures, slightly trickier. Alright, I know some of you might struggle with that concept, and it's a difficult concept to understand, 0.48. So, as that number stands, it has 1, 2, 3, 4 significant figures. Okay, we want to round to 2 significant figures, so much like the decimals, the third, it's always the place after this, so the third place value here, the 4, is going to decide what we do to that, and it's below the threshold for rounding. The threshold for rounding is 5, so to round to 2 significant figures, this 4 does nothing to the 5, so it stays as 25 millimetres. So there's the first 2 marks. Okay, if I come down here, resistance of a circuit is 3146 ohms. Write this in scientific notation. Don't worry about this unit. It's a measurement of resistance and electricity. Okay, don't need to worry about it. So when you're writing in scientific notation or standard form, you want times 10 to the power of something. You want this number at the start to be between 1 and 9.9. Okay, so this number here is going to be between 1 and 9.99, and you're going to have a power in here. So 3146, you want to move the decimal from where it exists in the number currently, which is there, to in between the first 2 significant figures. So the decimal needs to move there, and I know there's not a decimal given to you there, right? But you think about that as your bank statement. If you have £3,146, when you print your bank statements, oh, didn't mean to zoom that in there. I was just lent on something. Your bank statement would read £3146.00. Alright, they would give you that. So the decimal does exist, it's just not shown. It needs to go 1, 2, 3 spaces. So your final answer is going to be 3.146, and yes, you need to leave the trailing, like 1.146 times 10 to the power of 3, and it's to the power of 3 because I moved it 1, 2, 3 spaces. So again, no working really required. That's just there as a kind of visual. That's your final answer. Okay, don't leave it in this form. Don't try and fire on a times 10 to the 3 there. You want to write your answer nice and clearly. Alright, down here again, capacitor takes 1.67 times 10 to the negative 4 seconds to charge. Write this number in full. So you want to change this from scientific form to a number, and straight away what should stand out to you is a negative power, which means it's a really small number. So I'm going to fire some zeros in before it. Okay, 167. So again, we want to move the decimal from where it is currently there 4 spaces, because that's negative 4, back this way. So 1, 2, 3, 4. So the decimal is going to end up there. So you can almost ignore this first 0. So you then want to rewrite that number out in full, nice and clearly. So your final answer is going to be 0.000167. Okay, so there's 4 marks for the first 4 questions. Okay, I'll mark a piece. Now we're going to go on to using scientific form in context. So the stress on a beam is found, and you'll see these marks. These are 2 marks a piece, so there's going to be 2 steps involved here. The stress on a beam is found by dividing the applied load by the area of the cross section. So we're going to take the load and divide it by the cross section. Okay, so I know there's a lot of text in there, but all you're going to do is take these 2 numbers and do something with them in terms of multiplying. Well, we're going to divide them. You just need to get the order correct. Okay, so there's your load, and the cross sectional area is this. So it's load divided by the area. So 1.8 times 10 to the 4 divided by 3.7 times 10 to the minus 3. Okay, now, writing that out like that's not going to get you anything. You need to actually go to your calculator, but there's going to be 2 steps we're going to need to do. Okay, so 1.8. Remember, if you're using your calculator, the times 10 to the power button is down here. Alright, and I would advise using one of these because it's difficult to explain how to do that using your phone. Scientific notation on your phone is not easy. Right, sorry for these pop-ups because my screen's dead sensitive and when I lean on it, stuff just fires up. So times 10 to the 4. Right. Times 10 to the 4, close the brackets, divided by 3.7 times 10 to the negative 3. Okay, hit equals, you're going to get that 486. Oh, 486. 4.865. 4.865. Alright, now there's 1 mark. For firing that into your calculator and getting that as your answer, you're going to get a mark. But the last bit we need to do, it says give your answer in scientific notation. Alright, so we're going to change this to scientific form, which is what you did previously. So you want to move the decimal from where it is in the number now to in between the first 2 significant figures. So the first 2 significant figures there are 4 and 8 in between the first 2 numbers. You just need to figure out how many spaces you need to jump it. So 1, 2, 3, 4, 5, 6. So your final answer is going to be 4.864864865 times 10 to the power. What do we say? 1, 2, 3, 4, 5, 6. Now, even me just saying that sounds a bit laborious. So I would round it as well. I would round it to 2 decimal places as well. So if we round this to 2 decimal places, it's going to stay as 4.86. Okay, so put it as 4.86 times 10 to the 6. So all I've done there is I've done a combination of things, right? Because I don't want to be writing 4.864865 times 10 to the power of 6, because that's just stupid. Right, 1, 2, 3, 4, 5, 6. Yeah, it was 6. That is no neater. The whole point in scientific notation is that you can write large numbers in a much neater form. Okay, but if we round this to 2 decimal places as well, okay, so there's my decimal, there's my 2, so there's my first, second, third. Remember, if I'm rounding to 2 decimal places, my third decides, so my third is going to jump, sorry, my third here is a 4, which is not going to do anything to that 6 because it's below the threshold for rounding. Okay, so have a think. If you were going to write that as your answer, have a think, is that a better, neater way of writing my answer? And it's not. So all I've done here is I've combined scientific notation and rounding in one to get my answer. Okay, so next one, simplify 1.5 times 10 to the 2 plus 3.8 times 10 to the 3. Give your answer in scientific notation. Okay, so same thing again. 1.5 times 10 to the 2 brackets plus 3.8 times 10 to the 3, close the bracket, same thing again. You're going to get a mark for firing that into your calculator and writing a number, and then you're going to get a second mark for changing it to scientific notation and rounding if necessary. Okay, so there's my calculator. So 1.5 times 10 to the 2 plus 3.8 times 10 to the 3. 3950. Alright. So there's 1 mark, and the next mark I'm going to move. So even though there's no decimal, remember decimal exists there, you want to move it to there. So it's going to go 1, 2, 3 spaces. So it's going to be 3.95 times 10 to the 3. And I'm not overly fussed about rounding that because that would just round up to 4. It's not as ridiculous a number as I got back here. Okay, but you could round, if you rounded that up to 4 times 10 to the 3 or 4.0 times 10 to the 3, you wouldn't be wrong. Okay. Okay, so question 4 is moving on to percentages. The frequency of a signal changes from 50 Hz to 51.3 Hz. Express this change as a percentage of the original frequency. Okay, so you want the percentage increase. Your answer as a percentage. Okay, so there's a couple of ways you can look at this, and people do think about this differently. All right, I think about it as the change over the original. Right. Some people talk about it as like new minus the old, over the old, that sort of thing. The most important bit is that you multiply your answer by 100. Right, multiply by 100 because that is going to change it into percent for you. Okay, so the change over the original times 100. So change 50 to 51.3, easy. You can do a wee takeaway on the side, but it's a 1.3 hertz increase. Don't need to worry about the units. The original was 50 times 100. My calculator opens, I can fire this in. Right, so again, you can do this as a division. You can do that in one or two ways in your calculator. Right, if you don't like doing, I was going to do a fraction, so I was going to make that the wee fraction button up here below the absolute. 1.3 over 50 times 100 gives you that. If you change that to a decimal using this SD button, changes from what's known as a third to a decimal, 2.6, and your answer will be in percent. What you could also have done here, and it would have made no difference, a fraction is a division. So see if you don't have that option in your calculator, what you can do is just go 1.3 divide by 50. Oh, divide by 50 times 100. Alright, that does the exact same thing. Alright, so if you don't have the fraction button, or if you just don't want to use it, 1.3 divide by 50 times 100 gives you the same answer. Okay, so your answer, the final answer is 2.6. Remember, put the percentage sign in because your answer is a percent of the original, because 1.3 is 2.6% of 50, so there's been an increase of 2.6%. Okay, and the 3 marks come from finding the change, completing this, dividing it by 50 and changing it to a percent, which is the multiply by 100. Okay, next bit, the volume of a gas is 230 centimetres cubed. Calculate the new volume if the volume increases by 6%. So percentage increase. So first things first, I want to take a percent of 230. I want to find what 6% is. So 6 divide by 100 times the quantity. Percent divide by 100 times the quantity. Okay. By 100 times 230 is going to give you 13.8. So 13.8 centimetres cubed is 6% of 230. It's a volume increase, so all we would then do, I'll say V new as a new volume is 230 plus 13.8 and write that out. Make sure you write it out. I know you're firing it into your calculator, but just write 230 plus 13.8 in writing so it's clear that you've added 243.8 centimetres cubed. Okay, that one's nice and easy. Right, turns on the primary to secondary coils of a transformer is 1 to 4. If the total number of turns on both the coils is 540, determine the number of turns on each coil. Right, so I always think for ratio questions, you want to lay all your information out. We've got primary to secondary. Oh, primary to secondary in the ratio 1 to 4. Okay, so remember, that's the 1, that's the 4. When you read it left to right, when it's primary to secondary, it's 1 to 4. Okay, and we want to figure out the number of turns on each coil. You know the total turns made by both combined is 540. Alright, so we know that 5 shares, if you like, as in if the secondary gets 4 and the primary gets 1, there's a total of 5 shares. 5 shares, there's a total of 540. You need to figure out what 1 share is going to be. Okay, so you're going to go 540 over 5, divide by 5, to find what 1 share is going to be. 108. Okay, so 1 share, because remember there's 5 in total because the primaries get 1, the secondaries get 4, so 1 share is 108. So straight away I can look at this and say, well, if the primary has 1 of those shares, it's got 108 turns. How did I figure out this? This is 4 times this, so we'll do a multiplication. So 4 times 108, and again I would just always write it all down. Okay, will give you 432. Right, so therefore the secondary has 432. Okay, so that's how it's done. Pretty standard. Ratio share, figure out what one share is worth, and then come back to your original ratio split and do a multiplication to figure out what they're both going to be. Okay, last but not least, right, brass has a ratio of 7 to 3 copper to zinc. So again, I would lay all your information out. Copper, zinc, you've got 7 to 3. Right, so that's that bit of information laid out. How much copper has to be melted with 24 kilograms of zinc to make the brass? So we know we have 24 kilograms. Alright, you just need to figure out what this is going to be. Now, the numbers aren't too bad. So some of you might be sitting there thinking, well, if 3 shares is worth 24, 24 divided by 3 is 8. So therefore that times 8 gives you that. So we do the same to this side. Times by 8. Alright, and 7/8 are going to give you 56 kilograms. Another way you can do it is want over got times what you had. So 24 divided by 3, which is what we've done there. Multiply by your known quantity on the other side, 7. Alright, there's a couple of ways you can do it, as long as, and please do working for this, as long as you show whether you're doing a multiplication or a division and then another multiplication on this side. So write all this stuff down, because this is how you get your working. It's how you get your marks, by showing your working. Alright, if I go back to the last question as well, I wrote down I did 540 divided by 5, and then I wrote down that I did 4 times 108 to get this number. Alright, back up here again, there's my working to get the percent, the 6%, and there's how I got the new volume. Even though it's a nice wee simple addition, still write it down, just make sure you're showing your working. Here, a bit more complicated, you could have broken this down into its individual component parts. As long as you get this change being 1.3 divided by the original, times it by 100, you're fine. Up there, easy working in the calculator. Just remember how you convert these numbers to scientific form. Okay? Right, any issues, please let me know.